Good evening, everyone. Let's just wait for 5 minutes so that everyone can join. So today we'll be solving some heat equations. Mainly we'll be using the method of separation of variables. Let's see how does the solution of a heat equation looks like. So let's start with the first question. Let uxt be the solution of the following heat equation. We all know that heat equation is given by equal to ut. Here we'll be taking C to be 1. Where this C is actually, it depends on the conductivity of the material with the with initial conditions with boundary. For all T positive, 0 less than X less than L, boundary conditions. U 0 T equals to 0 is equal to U L T. That means the temperature at the end of the rod, that we can see this problem says that uxt gives us the temperature at time t and at position x of the rod. We can assume it to be a rod of length L, and which for the system, or we can say the rod, the temperature of the rod at the end points, that means at x equals to 0 and x equals to L is 0. So we can assume that the rod is insulated at the end points, and in between the temperature is flowing, which at time t and position point x we can find temperature as uxt. Now show that uxt tends to 0 as t tending to infinity. That means the temperature at time tending to time t tending to infinity is 0. That means eventually the temperature will come out. Uh, the temperature will go down to 0. So let's see solution. So we'll be solving it using separation of variable method. That means we'll assume uxt to be a function of uxt to be equal to some function x times some function t, where x depends completely on variable x and t depends completely on variable t. So let uxt is equal to xx t t. So let's mark this as 1, this as 2. By equation 1, we have x double dash x by xx is equal to t dash t by dt. Now we can see that the left hand side is a function of x, and the right hand side is a function of t, and they both are equal. So this can be possible only if this is equal to some constant lambda. So let's mark this as equation 3. And by second, we have 0 is equal to u0t. This is for every t positive. So u0t is basically x0 tt for every t positive. This implies x at 0 must be 0 because t is non-trivial. Similarly, we have 0 is equal to u lt, which is xl tt for every t positive, and this will imply that x at L is 0. So let's mark this as number 4. So by third, we have x double dash x is equal to lambda times x. Its auxiliary equation is given by r square equals to lambda. Along with, we have the boundary condition x0 equals to 0 is equal to x at L. So again, as we did in earlier sessions, we'll consider the cases lambda equals to 0, lambda positive and lambda negative. Case 1, lambda is equal to 0. So in that case, r is 0, 0. This implies x is equal to c1 plus c2x. And since x0 is 0, which is equal to xl, we will get x is 0 for every x. That will give us that the function uxt is a trivial function. That is not what we need. We are in search of a non-trivial solution. So case 2, when lambda is positive, that means lambda is equal to some gamma square for some gamma non-zero. That will give us r square is equal to gamma square, and in that case we know that the function x is given by c1 e to the power gamma x plus c2 e to the power minus gamma x, because this implies r is equal to plus minus gamma. Now let's look at the boundary conditions. So 0 is equal to x at 0, which is c1 plus c2, and 0 is equal to x at L, which is equal to c1 e to the power gamma L plus c2 times e to the power minus gamma L. Now from above equation we know that c2 is equal to minus c1, so we can write it as minus c1 e to the power minus gamma L, which is c1 e to the power gamma L minus e to the power minus gamma L. This implies that c1 is 0, because if c1 is non-zero, that means e to the power gamma L is equal to e to the power minus gamma L. Now since exponential function is a 1-1 function, this can never happen, not possible. So we are left with c1 is equal to 0, and this implies c2 is 0, which implies x is a trivial function, which will imply that u is a trivial function. That is not what we want. So we'll move forward to the third case. This case, hopefully we'll get some non-trivial solution. Case 3, when lambda is negative, that means lambda is equal to minus gamma square for some gamma non-zero. So from here we get r is equal to plus minus gamma iota, which implies x is equal to c1 cos gamma x plus c2 sin gamma x. Now let's look at the boundary conditions. We have 0 is equal to x at 0. X at 0 is c1. So this implies x is just c2 sine gamma x. Now we have another boundary condition. 0 is equal to x at L, which is c2 sine gamma L. Now we want C2 to be non-zero, because if C2 is also 0, then again we'll get x to be a trivial function and we'll end up being getting the trivial solution, and that is not what we want. So for C2 to be non-zero, we must have gamma L equals to n pi. So this implies gamma should be equal to n pi by L, which implies that our lambda is equal to minus n pi by L square. Now since it is depending on the natural number n, I'll denote it as lambda n. And corresponding to lambda n, the solution xn is some constant coefficient Cn times sine n pi x by n. Now corresponding to this lambda n, we need to find Tn as well. Now by equation third, we know that Tn satisfies Tn dash equals to lambda times Tn. Now, by third, we have Tn dash by Tn is equal to lambda n. And what is lambda n? Minus n pi by L square. Now integrating both the sides, we get ln Tn is equal to minus n pi by L square times T plus ln C. Let's write it as an. So this gives us Tnt is equal to an times e to the power minus n pi by L square t. Now we'll be using the principle of superposition. This implies by the principle of superposition, we have uxt is equal to summation n from 1 to infinity. I'll take some other constant bn e to the power minus n pi by L square t times sine n pi by L x. Now what were we supposed to prove? We had to prove that uxt tends to 0 as t tends to infinity. Now see, here uxt, we have e to the power minus n pi by L whole square t. Now since n pi by L whole square t is tends to infinity as t tending to infinity, or we can say that minus of this tends to minus infinity as t tends to infinity. This implies e to the power minus n pi by L square t will tend to 0 as t tending to infinity, which gives us that uxt tends to 0 as t tends to infinity. I hope this solution was fine with everyone. I would like you to go through the solution once again, and if you have any doubt, please let me know. let's move to the next question. Question number 2. Determine the solution of one-dimensional fluid equation ut equals to c square ux under the boundary condition u is equal to t for every t positive. That means the rod is insulated at the boundary point, at the boundary, and that means the temperature at the end points is 0, and the initial condition, that is at time t equals to 0, and the initial conditions condition ux at 0 at time t equals to 0, ux is equal to x for every 0 less than x less than l, l being the length of the rod. Now I would like you to try this question first. Start with taking uxt equals to xx and tt. Then you'll have some initial conditions. X0 equals to 0 is equal to xl, and let's number this one as 1, 2, 3. So if when you'll put uxt, the value of uxt in equation first, you'll get something like this: x double dash by x, sorry, equals to t dash by t equals to some lambda. Using this and these initial conditions, I would like you to see for different cases of lambda when we are getting non-trivial solution, and in that case what will be t. So I'll just wait for 5 to 10 minutes, because otherwise there's no use of just directly solving these questions. I would like you to go through this and find the solution. If you have any, if you are stuck in between, don't worry. I'll be solving all the steps. But first, I want you to try it yourself. So I'll just wait for 5 minutes. You try it. After that, we'll solve. Mainly, you have to follow the same steps as done in the question number 1. So let's start from the scratch. I hope you all must have got the solution, but for the recording purpose, let me do it once again. So we start with taking uxt to be xx This implies by first we get t dash t times xx is equal to c square x double dash x dt, which basically gives us x double dash x by xx is equal to t dash t by tt. Now, on either side of the equation, we have different independent function. On the left hand side, it is a function completely depending on x, whereas on the right hand side, it is a function that depends completely on t, and they both are equal. So this can be possible only if they are equal to some constant lambda. So this gives us x double dash x minus lambda xx is equal to 0. Also, uh, t dash t minus lambda dt is equal to 0. So let me mark this one as number 4th. By the boundary conditions given in equation 2, we will get, as we did in the last question, we will get x0 is equal to 0, which is equal to x at L. So now after taking, as done in the previous question, we take different cases. For lambda equals to 0, we will end up getting x equals to 0. For lambda positive, in that case also we'll end up taking x equals to 0. I hope you all must have done this when I give you the time to solve yourself. For lambda negative, we take lambda to be equals to minus k square for some k non-zero. So let me mark this as 5th, both the equations. By 5th, the auxiliary equation for x double dash minus lambda x is equal to 0 is r square equals to lambda, which is equal to minus k square. So this gives us r is equal to plus minus k iota, and as done earlier, we have xx is equal to c1 cos kx plus c2 sin kx. Now we have the boundary condition 0 equals to x0, which is equal to c1. This implies 0 equals to x at L, which is equal to c2 sin kl, and this will imply that kl equals to n pi. Therefore, lambda equals to minus n pi by L whole square. All these are just repetition of what we did in previous question. So since this lambda is depending on n, I'll write it as lambda n, and corresponding xn is cn sin n pi by L x. Now corresponding to this lambda n, we need to find Tn. Since Tn dash by Tn is equal to lambda n, which is equal to minus n pi by L square. Integrating both the sides, we'll get ln Tn is equal to minus n pi by L t plus ln some constant a. So this gives us Tn t is equal to an e to the power minus n pi by L whole square times t. This implies, by the principle of superposition, we will get uxt is equal to summation n from 1 to infinity some other coefficient dn, bn, I'll write it as bn, which is just an times cn, bn e to the power minus n pi by l square t times sine n pi by l x. So if we look at the question, till now we have used equation first and second. We need to use equation third and find the explicit form of the function uxt. So we have, by equation third, we have ux0 equals to x. This implies by third we have x is equal to ux0. Now putting t equals to 0 here, we get, since e to the power 0 is 1, we have this is equal to summation n from 1 to infinity bn times sine n pi by l x. Now from here we know how to evaluate these coefficients bn. They are basically integration 0 to l x times sine n pi by l x by 0 to l sine square n pi by l x dx. Now 0 to l sine square n pi by l x dx is equal to 0 to l 1 minus cos 2n pi by lx by 2 dx, just 1 by 2 x minus integration of cos x is sin x. So this is sine 2n pi by l times x by 2n pi times l 0 to l. Now since sine 2n pi is 0 and sine 0 is 0, we are left with l by, and the numerator term, and 0 to l, what is in the numerator? X times sine n pi by l x, x sine n pi by l x dx. Here we'll be using integration by parts. This is equal to x as it is. Integration of sine is cos minus cos n pi by l x by n pi times l 0 to l minus integration 0 to l. Derivative of x is 1 and integration of sine is minus cos. So this is cos n pi x by l by n pi dx. So this is equal to minus l by n pi. Putting x equals to l, we get l times cos n pi. We know that cos n pi is minus 1 to the power n. Minus, putting x equals to 0, we are left with 0. Plus l by n pi times integration of cos x is sin x. Sin n pi x by l n square pi square l square 0 to l. Now since sin n pi is 0, sin 0 is 0, we are left with minus 1 to the power n plus 1 l by n pi. Therefore, bn is minus 1 to the power n plus 1 l by n pi times l by 2. Sorry, this was l square here. So this is l square, later way 2. So this is minus 1 to the power n plus 1 2 l by n pi. Therefore, uxt is equal to summation n from 1 to infinity 2 minus 1 to the power n plus 1 L by n pi e to the power minus n pi by L square n pi by L square t sine n pi x by L. This is the explicit form of the solution of our given heat equation. So I hope this solution was fine with everyone. If you have any doubt, please let me know. We have basically used the same procedure as done in the previous question till here, and after that, using the initial condition, we have found these coefficients bn. If you have any doubt, please let me know. Let's move to the next question. Find the temperature in a bar of length L with both the ends insulated, sorry. So there is no passage of heat through the end, and the initial temperature in the rod is sine pi x by L. So this is basically a statement based problem. We need to convert this into a numerical problem. So we need to find the temperature. That means we need to solve the heat equation, which is given by, we know that it is equal to ut equals to c square uxx for every t positive, and x gives us the position. That means position on the rod. So since the length of rod is L, we have 0 less than x less than L. Then we know that both the ends are insulated. That means at the end points there is no transfer of heat. That means at that point the temperature can be taken as 0. So we have u 0t is equal to 0, which is equal to u LT for every T positive. Then we are given that the initial temperature in the rod at point X is given by this function sine pi x by L. That means ux0 is equal to sine pi x by L for every 0 less than x less than L. So now we are in the setup as we have done earlier. So again, I would like you to solve this first. It will be exactly similar to the previous question number 2. And I want you to do all the steps and reach up to the point where we get uxt is equal to summation n from 1 to infinity, some constant b in time e to the power minus n pi by L. Oh, we will have c as well. No? Mm, so in the previous question, I think I left something. Yes, here we had Tn dash by Tn equals to c square times lambda n. Oh, I did this mistake in the last question. That it won't affect our solution that much. It's just that we will have this c square as well. So this is from here to c square as well. So that will give us Tnt. So we will have a c here, c here, c here, c here. So since we didn't had c with x, so these coefficients will still be same. And c here. So I would like you to go through all these steps once again and reach up to the point when we will get uxt equals to bn summation n from 1 to infinity bn times e to the power n pi c square times t sine n pi by l times x. After that, we'll be using this condition ux0 equals to sine pi x by l to get an explicit form for our solution. I'll wait for 10 to 15 minutes so that you can go through all these steps once again and reach up till this point. Till here, everything will be same. So I hope you all must have got this solution uxt. If you have any doubt, you can go through the earlier lecture videos. So till now you must have used only the boundary conditions. Now we'll use the initial condition to get to find an explicit form. That means we'll end up finding the coefficient bn. So let's number this as equation 1. We have by first sine pi x by l is equal to ux0, which is equal to, putting t equals to 0, we know that sine e to the power 0 is 1. We have this is equal to summation n from 1 to infinity bn times sine n pi by l x. From here we know we can evaluate these coefficients bn. It is given as integration 0 to l sine pi x by l times sine n pi x by l dx by integration 0 to l sine square n pi x by l dx. We can say that for n equals to 1, the numerator and the denominator are eventually the same. So we have b1 is equal to 1. Now we need to find bn for all n not equals to 1. As you remember, we had evaluated this denominator earlier in question number 1. So by question 1, we know that this denominator 0 to l sine square n pi x by l dx is nothing but l by 2. So all we need to find is the numerator. Now integration 0 to l sine pi x by l times sine n pi x by l dx. We can just multiply it by 2 and divide it by 2. We know that 2 sine a sine b is cos a minus b minus cos a plus b. So this is 1 by 2 integration 0 to l cos n minus 1 pi x by l minus cos n plus 1 pi x by l dx. Now since integration of cos x is sin x, this is 1 by 2 integration sin n minus 1 pi x by l by n minus 1 pi times l minus sin n plus 1 pi x by l by n plus 1 pi times l integration limit is from 0 to l. Now since sin some integer times pi, sin z pi is equal to 0 for every z integer, we have this is equal to 0. Since sin k pi is equal to 0 for every k being an integer. So this gives us Bn is equal to 0 for every n not equal to 1. Therefore, uxt is basically just b1 times e to the power n pi by n pi c by l whole square minus t times sin n pi by lx. Since bn is 0 for every n not equals to 1, we are left with just b1 times all those things, and b1 is 1. So this is just e to the power minus pi c by L square t sine pi by L x. So this is the explicit form of our solution. So I hope this was fine with everyone. Let's move to the next question. Question number 4. This is again a statement based question problem. A bar of length L laterally insulated, that means it is insulated at both the ends and the heat cannot flow outside it. Insulated at its ends A and B and kept at 0 degrees Celsius and gamma degrees Celsius respectively. So at the end A, the temperature is 0 degree. At the end B, the temperature is gamma degrees and it is kept constant like this throughout respectively until steady state condition, until steady state condition prevails. So by steady state condition we mean that the situation where the temperature is not changing with respect to time. That means for even if time is changing with increasing or decreasing time t, the temperature remains the same at all the points of the bar. That means again uxt, basically uxt is independent of t at the steady state condition. Now if the temperature at B, if the temperature at B is suddenly reduced to 0 degrees Celsius and kept so while that of A is maintained 0, maintained at 0 degrees Celsius, find the temperature temperature in the bar at any subsequent time. Now to understand this problem we need to understand the story behind what they are asking. So see, initially let this be a rod, this be point A and it is the point B. So initially we have kept the temperature at A to be 0 degree Celsius, at B to be gamma degree Celsius, and the condition is steady state. That means the temperature uxt at any point x at any time t is independent of x, independent of t. So initially we were in a situation where temperature at A is 0, temperature at B is gamma, and at any point x on the rod, it is independent of time t. So we are in steady state condition. Now, at some point, at some time, we write it as, we denote it as t equals to 0. At t equals to 0, suddenly the temperature at point B is reduced to 0 degree Celsius. So at time t equals to 0, the temperature, we can write it at for every t negative. And at time t equals to 0, the temperature at point B, so if the length of rod is L, let us suppose this to be 0 to L. So the temperature at point L at time t equals to 0 is 0, and it is maintained 0 at point A as well. And it is, sorry, maintained. So for every t positive. So before time t equals to 0, the condition was that the temperature at A is 0, temperature at B is gamma, and the temperature at any point is independent of t. That means uxt is just ux, and after time t equals to, and at time after time t equals to 0, the rod is maintained in such a way that the temperature at point A is 0 and temperature at point B is also 0 throughout. So we need to find the temperature in the bar at any subsequent time. That means after time t equals to 0, at time t, what is the temperature at any point x. So we need to eventually solve, we need to solve the heat equation given as ut equals to c square times uxx with some boundary condition. Boundary condition is this: ult is equal to 0, u is equal to u0t for every t positive. And since before time t equals to 0, this rod was at steady state, we have, we had, and before time t equals to 0, we had uxt is equal to ux. That means del u by del t is 0. That is c square uxx, which is equal to ut, is 0. This implies uxx, or it is, this is just u double dash x is 0 for every, in fact I will write it as less than equal to 0. For every t less than equal to 0. This gives us ux is some c1 times x plus c2 times just c2. Now also initially we had u at point 0 is 0 degree Celsius. Also u at 0 is 0 with u at L at point B, the temperature was gamma. So from here we get 0 is equal to u0, which is equal to c1, c2. So this implies ux is just c1x. Also, gamma is equal to u at L, which is c1 times L. So this implies c1 is L by gamma. So this gives us ux is equal to L by gamma times x. Now this is the scenario for t less than equal to 0. So this gives us ux at time t equals to 0 is L by gamma times x. So from here we need to solve the system this first and second. From first and second we need to solve the system ut is equal to c square uxx with the boundary conditions u0 t equals to 0 is equal to u lt and the initial condition, because before time t equals to 0 we know that this situation was very ideal. The temperature was kept constant at all the points. It was independent of time t. It was just depending on the position. And after time t equals to 0, the scenario changed. So what was the scenario after that? At time t equals to 0, whatever it was in the initial state, earlier stage, so ux 0 will be same as whatever it was earlier, ux, so which that is basically L by gamma times x. At the end points we are maintaining temperature 0, so we need to solve this for every t positive, and this is for every 0 less than x less than L. So basically we need to solve this problem. I hope you all understood how we deduced the system that we needed to solve from the statement. Now I would wait for 5 to 10 minutes so that you can solve the system. So basically, again, you'll have to take the method of separation of variable. You'll take uxt to be function xx times tt, and using the boundary conditions and the equation ut equals to c square uxx, you will end up getting uxt is equal to summation n from 1 to infinity some constant bn times e to the power minus n pi c by l square t times sine n pi x by l. So I'll just wait for 5 to 10 minutes so that you can get up till here. After that, we'll be using the initial condition to find these coefficients bn. So I hope you all were able to find the solution of this problem given as uxt is equal to summation n from 1 to infinity some coefficients bn times e to the power minus n pi by l t square t times sine n pi by l x. Now using the initial condition, we have L by gamma times x is equal to ux 0. Putting t equals to 0, since e to the power 0 is 1, we have summation n from 1 to infinity bn sine n pi x by l. From here we know how to evaluate these coefficients bn. This bn is equal to integration 0 to L by gamma x sine n pi x by l dx by 0 to L sine square n pi x by l dx. As we had done in earlier questions, we know that by question 1, we know that this denominator integration 0 to L sine square n pi x by l dx is equal to L by 2. Now we need to find the numerator. Now integration 0 to L by gamma x sine n pi x by L dx is equal to, so we'll be using integration by parts. This is L by gamma times x as it is. Integration of sine is minus cos, so this is minus cos n pi x by L times L by n pi, limit is from 0 to L, minus integration 0 to L, derivative of x is 1 and integration of sine is minus cos n pi x by L by n pi dx. So this is L by gamma minus L by n pi, putting x equals to L, since cos n pi is minus 1 to the power n, this is minus 1 to the power n, and x equals to 0, minus 0, plus L by n pi. We know that integration of cos x is sin x, sin n pi x by L, n square pi square L square, integration 0 to L. So this is minus 1 to the power n plus 1 L cube by gamma n pi, gamma times n pi, plus L cube by gamma n square pi square. Since sin n pi is 0, sin 0 is 0, this is just 0. So this gives us bn is equal to minus 1 to the power n plus 1 L cube by gamma n pi times the denominator was L by 2. So this is two minus 1 to the power n plus 1 L by n pi gamma. Therefore, uxt is equal to summation n from 1 to infinity 2L minus 1 to the power n plus 1 by n pi gamma e to the power minus n pi c by L square t times sine n pi x by L. So this is the explicit expression for our solution UXT. I hope this was fine with everyone. So the main important thing in this question was to formulate this numerical form, or we can say the mathematical form of the word problem. So we were actually given a kind of story, and we ended up making a mathematical system that represents that scenario. And after using the same methods that we had been using earlier, we found the solution for that problem. So if you have any doubt, please let me know. I'll wait for 5 minutes and then we'll go to the last question for this session. Let's move to the next question. Question number 5. Find the temperature in a rod of length L and conductivity K, which is at uniform temperature of 50 degrees Celsius. Suddenly, So the rod initially it was kept with the uniform temperature throughout the rod. Everywhere the temperature was 50 degrees Celsius. Now suddenly at time t equals to 0, the end x equals to 0, the end x equals to 0 is cooled to 0 degrees Celsius by an application of ice. So at the end x equals to 0, we have applied some methods to reduce the temperature. So from 50 degrees Celsius, suddenly it is dropped down to 0 degrees Celsius. And at the end at the end L, x equals to L, it is x equals to L, and the end x equals to L is is heated to 100 degrees Celsius. So at x equals to L, the temperature is increased, whereas at x equals to 0, the temperature is reduced 100 degrees Celsius by an application of steam. And these two temperatures are maintained at ends. So after time t equals to 0, at every time t, strictly positive, at the end x equals to 0, the temperature is 0 degrees Celsius, and at the end x equals to L, the temperature is 100 degrees Celsius. Is maintained at temperatures are maintained at both ends. Furthermore, the rod is insulated along its length. That means the heat is not transferred outside the rod. The rod is insulated along its length. Length, so that no transfer of heat can occur. Now we need to formulate the mathematical problem given from this statement problem. So since we need to find the temperature, we need to solve the heat equation, which is given as ut is equal to k square times uxx. Then there is a uniform temperature of 50 degrees Celsius on the whole rod. We can see that at time t equals to 0, the temperature is changed at the end points, but at the rest of the points, the temperature is still same. So we have ux0 is equal to 50 for every 0 strictly less than x and strictly less than n. At the end x equals to 0, we have maintained a temperature of 0 degrees Celsius. We have maintained the temperature of 0 degrees Celsius. So 0 T is equal to 0 for every T positive. And at the end L, we have maintained a temperature of 100 degrees Celsius for every T positive. Now, if we start with our standard way of solving these kind of problems, in this case, suppose if we start with uxt, taking uxt to be xx and tt, so here the initial the boundary condition will give us u0t is 0 is equal to u0t, which is equal to x0 and tt for every t positive. This will imply that x at 0 is 0, but the other condition in the other bound in the on the other hand, on the other boundary condition, we do not have 0. So this is basically x, sorry, xl times tt for every t positive. This does not imply that x at l is 0, and hence we cannot use whatever we were doing earlier, because here we won't be getting trivial solution in case of lambda being 0 and positive, so we cannot use those methods. So instead we will try to find solution to some other problem that is similar to what we have been solving till now. So we take uxt to be equal to vxt plus some function gx, where g is such that g double dash x is 0, g at 0 is 0, and g at l is 100. So this will imply that u xx is basically equal to vxx, because g double dash is 0 for every x. Then we have u0t is equal to v0t plus g0, which is v0t itself because g0 is 0, and ult is equal to vlt plus gl, which is vlt plus 100. Now we want ult to be 100. So if p is such that it satisfies vxx, sorry, from here we have ut is equal to vt, vt equals to k square, k square vxx. Then we have v0t is equal to v0, which is equal to vlt, and vx0. So ux0 is basically just vx0 plus gx. And vx0 is equal to ux0 minus gx. So ux0 was 50 minus gx, where g satisfies system star, and V satisfies the system hash. Then what do we have? We have UT. Now suppose we have taken UXT to be equal to VXT plus GX, where G satisfies the system star and V satisfies the system hash. From here we can see that UT, which is UT will be derivative of U with respect to T, will be equal to VT. Now this is from hash, this is equal to K square VXX, and from the definition of UXT we know that uh, Vxx is basically just Uxx. Then we will have U0t is equal to V0t plus G0, which is, so by hash V0t is taken to be 0 and by star G0 is 0. So this is 0. ULT is equal to VLT plus GL. So by hash VLT is 0 and by star GL is 100. So this is equal to 100. And what other we want? We wanted GX0, VX0. VX0 is, sorry, UX0 is VX0 plus GX. So VX0 is 50 minus GX plus GX. So this is 50. Therefore, U is our required solution. So in order to find U, we need to find V and G. So let's solve the system hash. So this gives us, now since G double dash X is 0, this gives us Gx is nothing but C1x plus C2. We have just integrated both the sides twice. So and also we have G0 is 0. This gives us 0 is equal to G0, which is equal to C2. That means C2 is 0. This implies Gx is just C1x, and since 100 is equal to GL, which is equal to C1L, we have C1 equals to L by 100. Therefore, Gx is L by 100 times X. So this is Gx. Now we need to find V. So since V is a solution of system hash, uh, following the same methods that we had done in the previous questions, we get from here, we will get Vxt is equal to summation n from 1 to infinity Bn times e to the power minus n pi c by L square t sine n pi x by L. And also we have 50 minus gx is equal to vx0, which is equal to summation n from 1 to infinity Bn sine n pi x by L. From here we can evaluate Bn. This Bn is equal to integration 0 to L. 50 minus gx is basically 50 minus L by 100 times x sine n pi x by L dx by integration 0 to L sine n pi x sine square n pi x by L dx. We know that this denominator is basically equal to L by 2. So this is equal to 2 by L. So now we'll be using integration by parts. 50 minus L by 100 x as it is. Integration of sine is minus cos n pi x by L. L by n pi. Limit is from 0 to L. Minus integration 0 to L. Derivative of the first term will be minus L by 100. Integration of sine is minus cos n pi x by L. L by n pi dx. So this is equal to 2 by L minus L by n pi. Putting x equals to L. Since cos n pi is minus 1 to the power n, so this is minus 1 to the power n. 50 minus L square by 100. Minus cos 0 is 1, so this is just 50. Minus L square by 100 n pi. Integration of sine is cos n pi x by L. N square pi square L cube. Limit 0 to L. So this is 2 by L minus 1 to the power n plus 1 L by n pi times 50 minus L square by 100 minus plus 50 L by n pi minus L cube by 100 n square pi square. Cos n pi is minus 1 to the power n, so this is minus 1 to the power n minus cos 0 is 1. So this is minus 1 to the power n plus 1 by n pi 2 50 minus L square by 100 plus 100 by n pi minus 1 to the power n plus 1 2 L cube by 100 n square pi square plus by L, no? So the cell got cancelled out, and here we will have L square. So this is 2 L square by 100 n square pi square. That's it. So if you want, you can simplify it further, taking 2 minus 1 to the power n plus 1 by n pi common. Get 50 minus L square by 100 plus L square by 100 n pi plus 100 by n pi plus L square by 50 n square pi square. There might be some calculation mistake. Please go through this once again and check whether I have taken the correct coefficients. So basically our solution ux is just vxt plus gx. So I hope this solution was fine with everyone. I would like you to please go through these coefficients bn once again. There might be some calculation mistake. And yes, okay then, we'll meet next Friday and try to solve some other questions. I would suggest you to please go through the theory classes regularly so that you can understand why we are following this procedure to solve this type of problems, and what is the uh, basic things behind all these calculations, whatever we are doing. So thank you so much.